Day 144, Physics, Circuits, Problem 1B. This one turns out to be the simplest of the four problems here. Even though it might not look like it, it is, because bottom line is there's only one loop, one path. Everything here is in series. The 20, 10, and 30 are all in series. So really it's a one-step problem as far as the diagrams are concerned. It's extra steps for the calculations, but there's only one diagram, new diagram that you have to draw, and that is, because they're in series, it's a simple addition. In series, to combine the resistors is 20 plus 10 plus 30. So the new diagram is essentially, it's just this diagram. You got the battery, and combined it's a 60 ohm resistance. So you have 100 volts and 60 ohms. Just a simple series circuit, no parallel portions, one pathway. And as always, then we apply Ohm's law. V equals IR. We have 100 equals I times 60. I turns out to be 100 divided by 60 is 1.7 amps of current, rounded off to 2 sig figs. That's the current that's flowing, not starting from the battery. It starts anywhere you want to draw it. We usually draw it from the battery, even though it's everywhere, like, it's again like musical chairs. All the current starts up at the same time and starts to rotate or flow through the circuit. Going back to the original diagram then, the current flow, like this, is 1.7 amps. Each resistor has the same current, 1.7 amps. They have different voltages, because the rule in series is they all have the same current. Essentially, they have what's called additive voltages. Their voltages add up to 100 volts. I'm going to calculate them each separately, but I'll start with the 20 ohm resistor. I'm going to figure out the voltage for the 20 ohm resistor. It's going to be its current times its resistance. So for the 20 ohm resistor, the current flowing is 1.7 amps times 20 ohms of resistance. So I believe that comes out to be 34 volts. Switching colors here. I'll go black. So for the 10 ohm resistor, it's going to be its current times its resistance. So the current is still 1.7. Resistance is 10 ohms. So it's 17 volts, half the voltage of the 20 ohm resistor. And finally, the 30 ohm resistor is I times R for that resistor. It has the 1.7 amps. It's a 1.7 times 30, so it'll be 3 times the 10 ohm resistor. Comes out, and that comes out to be what, 51. So V30 is 51 volts, and those three values, these three values down here, should come out to be 100 volts. I think it's a little over. It's come out to be 102 or something like that. Let's see, 51, yeah, 102 volts. It's a little over, but it's close because I've been rounding off. I think we're ready to put the values in the chart now. Once again, this one's a little bit simpler than the other ones, simply because it was a one-step diagram problem. The current is the same in all these resistors. They all have 1.7 amps. 1.7, 1.7, 1.7, and the battery was pushing 1.7 amps of current. They have different voltages. The 10 ohm resistor was 17 volts. This was 34 volts, and this was 51 volts. The battery is 100 volts. And then I can figure out the final column. Power, once again, using this equation up here in the upper left, is just the voltage times the current. Multiply these two columns to get that. So I've done the math here. I've multiplied the voltage times the current to get the power. And this is the power supplied or given off by the resistors or light bulbs. For light bulbs, it would be light and heat. Those should add up to 170, and it's real close. It's a little over 170, but rounded off to 2 sig figs, it would be 170. The battery supplies that much power, and the bulbs transfer it to light and heat. Or if they're just resistors, they're just giving off heat.